All right. Hi, everybody. So, in section 6.2, we want to talk about the division algorithm and the remainder theorem and synthetic division. So, the question is now, how do we divide polynomials? How do we do that? And that's what this section is all about. We want to learn the division algorithm and remainder theorem, and we want to learn synthetic division. So, many of you have learned or seen before polynomial long division. Remember whenever you would have, say, I'm going to do it with numbers, for example. Remember you have 8, and suppose you want to divide 8 by 3. Then 3 goes into 8 how many times? Once, or twice, or 3 times, right? Which one? It goes in it twice. So you would have 2 here. Then you'd multiply the 2 times the 3. You get 6. So you subtract 6. You have a remainder of 2. So this is your remainder. So this process with polynomials is called polynomial long division. So that's what we're talking about in this section. But instead of numbers, we're going to be dealing with polynomials. So let's talk about the division algorithm. Let p of x and d of x be polynomials such that d of x is not equal to 0 and with the degree of d less than or equal to the degree of p. So we'll draw a picture to help us with that in a minute. Then there are unique polynomials q of x and r of x called the quotient, and the remainder, respectively, such that p of x is equal to q of x times d of x plus r of x. What in the heck? So let's put this together. So, moving this over a little bit. So this really means that we have a similar setup like so. We would have d of x being divided into p of x, goes q of x times, and then when you do q of x times d of x, you get something, so minus blah, and then you're left with some remainder r of x, okay? So all of that to say, p of x would be equal to q of x, which is our quotient, times our divisor, plus our remainder. So the terms, we have our dividend, we have our quotient, we have our divisor, and then we have our remainder. Okay? A few facts to remember. Either the degree of the remainder r is less than the degree of the divisor d, or the remainder is 0. If this is the case, we say d divides evenly into the polynomial p. If the remainder is 0, the two polynomials q and d are factors of p. So if the remainder is 0, then the two polynomials q and d are factors of p. Okay? And in this case, another thing that we can do is we can write p of x over d of x equals our quotient q of x plus our remainder over our divisor. So another way of thinking of this is, instead of this, and you're thinking of the phrases, that would mean your divisor is what you're dividing into your dividend. And then on top you have your quotient. Then you have some things here. You subtract, simplify, and you get your remainder. Okay? And the degree of your remainder has to be less than the degree of your divisor by the time you're done. Okay? Or 0. Okay, so let's talk about what this means in terms of zeros and linear factors, because putting all of this together in a minute is going to be helpful for us in the long run. The number c is a 0 or solution or root or x-intercept of a polynomial p of x if and only if the linear polynomial x minus c is a factor of p. Okay, the number c is a 0 if and only if x minus c is a factor of the polynomial. Okay, so this is just formalizing things that we've already pointed out in the previous section. A few facts. In this case, p of x is equal to the quotient, q of x, times that factor for some quotient polynomial q. This also means that c is a solution of the polynomial equation, p of x equals 0. So that also means c is a solution. Of this equation. And if p is a polynomial with real coefficients, and if c is a real number, then c is an x-intercept of p. So that goes back to saying that your zeros, your solutions, your roots, and your x-intercepts all mean the same thing. Okay? Now, the remainder theorem. The remainder theorem says that if the polynomial p of x is divided by x minus c, that linear factor, then the remainder is p of c. So the remainder would be the same thing as taking c and substituting it into your polynomial to see what you get. Okay, so in other words, p of x is going to be q of x, your quotient, times your linear factor x minus c plus p of c. Okay? It may seem a little abstract right now, but we'll do it with numbers and polynomials in a minute, so hold on, okay? Synthetic division. This is the party for this section. This is really the thing that you need to know. Synthetic division, the process. 1. Synthetic division is a shortened version of polynomial long division that can be used when the divisor is of the form x minus c for some constant c. So again, synthetic division is a shortened version of a polynomial long division that can be used when the divisor is of the form x minus c for some constant c. By the remainder theorem, synthetic division also provides a quick means of determining p of c, or your remainder, for a given polynomial p, since p of c is the remainder when p of c is divided by x minus c. If p of c is equal to 0, then we know that c is a 0 of p of c, and that x minus c is a factor of p of c. So this is important to make note here. That last step, if p of c is equal to 0, then we know c is a 0 of p of c, and that x minus c is a factor of p of c. So let's actually get our hands dirty. Let's look at some examples. X minus c being a factor, or what we're actually dividing by. For each polynomial p below, divide p by x minus c using synthetic division. Use the result to determine if the given c is a 0. If not, determine p of c. So in other words, determine the remainder. Okay? So in part A, p of x is equal to 12x to the 4th minus 7x cubed minus 32x squared minus 7x plus 6. And c is equal to 2. So what we're trying to do, or what we're trying to determine, is, remember when c is 2, that corresponds to, so here, our question really is x minus 2 a factor? That's the question. Okay? So it's important that whenever we're using synthetic division, that our terms appear in descending order by the variable of highest degree. And if something is missing, then we'll put in 0 as a placeholder. Okay? So I tend to set mine up this way with synthetic division. So if you want to watch this entire example first, watch the entire example, then go back and rewind your video and then write it out as you watch it. Okay? It helps for those who are highly visual. So you put 12, negative 7, negative 32, negative 7, and 6. So we take these coefficients and we put them here. You're taking the coefficients and the constant term, we put it there. Now C is 2. C is 2, so we're going to put this 2 here. You always bring your first term down, so 12. So then you have 12 times 2 is 24. So 12 times 2 is 24. Again, bring down the 12. 12 times 2 is 24. Then we add. Negative 7 plus 24 is 17. And then 17 times 2. So again, you're multiplying here. So 17 times 2 is 34. So you put the 34 here. Add. You get 2. Then 2 times 2 is 4. Put the 4 here. Now we add again. Get negative 3. Negative 3 times 2 is negative 6. Negative 6. And then we add 6 minus 6. That's 0. Well, this means, because we got 0 here, this means our remainder is 0. This means our remainder is 0. This means our remainder is 0. So that means x minus 2 is a factor, right? Because it says use the result to determine if the given c is a 0. Because our remainder was 0, that means 2 is a 0. Okay, so 2 is a 0. That's our final answer. Now, extra information, because you might be questioning what. So we can rewrite 2, this factor, x minus 2, divides evenly into this polynomial as p of x. We determined x minus 2 was a factor. If x minus 2 is a factor, that means these coefficients represent the coefficients of the polynomial that's 1 degree lower than this. So this would be times 12x cubed plus 17x squared plus 2x minus 3. These coefficients represent the coefficients of the polynomial of 1 degree less. Okay? The 0 here indicates that x minus 2 is a factor. So when you multiply these two together, you're going to get this p of x back. Okay? So what we just did was we did a shortcut for dividing this polynomial by x minus 2. So what we did, so on the side, just extra information. Synthetic division is a shortcut for polynomial long division. So in other words, you have x minus 2 dividing into 12x to the 4th minus 7x cubed minus 32x squared minus 7x plus 6. And whenever you divide this into this polynomial, you get this. You would get the 12x cubed plus 17x squared plus 2x minus 3. And granted, you would write down some work here. And after that work, you would find out that the remainder was 0. Okay? So again, synthetic division is a shortcut for this process. Okay? So now let's go through part B. P of x equals 8x to the fourth minus 2x plus 6, and c is equal to 1. P of x equals 8x to the fourth minus 2x plus 6, and c is equal to 1. So we're supposed to be using the result to determine if the given c is a 0. If not, we have to determine p of c. So we're dividing our polynomial p of x by the factor x minus c. So here, what's your factor? Your factor here, if you have c equals 1, that corresponds to x minus 1. So is x minus 1 a factor? So we're dividing it. If x minus 1 is a factor, we're going to have a remainder of 0. If it's not a factor, we're going to have some other number. Okay? So one thing to note when we look at 8x to the fourth, notice that we don't have a cube term, we don't have an x squared term, so we need to put placeholders in there. So p of x is really 8x to the fourth plus 0x cubed plus 0x squared minus 2x plus 6. Placeholders we need whenever we're doing synthetic division. Okay, so we have our 1 here. Then we take our coefficients, 8, 0, 0, negative 2, and 6. So 8, 0, 0, negative 2, and 6. Remember the process. Bring down your 8. Multiply 8 times 1. You get 8. Then add, you get 8. 8 times 1 gives you 8. Add, you get 8. Then multiply 8 times 1, you get 8. 8 minus 2, because we're adding negative 2 plus 8. That gives us 6. 6 times 1 is 6. Add 6 plus 6, we get 12. I encourage you to pause the video, rewind it. Make sure you understand this process. This is the number we ended up with. Is it 0? No, it's not 0. 12 is not equal to 0. This means, you can box it off if you want, but that's not our answer. This means our remainder is 12. This means our remainder is 12. So what do we get? 1 is not a 0 because our remainder is not 0. So that means this 1 that we started out with, where c is equal to 1, 1 is not a 0. P of 1, because if we had to use the result to determine if the given c is a 0, if it's not, determine p of c. So p of c is 1. P of 1 is equal to 12. Okay, and that's our final answer. That's part B. Okay, so you can do this with complex numbers. You can do this with complex numbers as well. So what we're really finding out here is if these numbers are zeros, then these are our x-intercepts. And we can determine a completely factored polynomial. Like we can continue this process if I give you a c and I ask you to find the remaining zeros. We can use this process. Okay, so part C. Part C of example 1. P of x is equal to x squared minus 6x plus 13. And c is equal to 3 minus 2i. So this is a complex number, but the process is still the same. So you will have your 3 minus 2i. And then we write down our coefficients. Let's see if anything is missing. You have x squared, then you have minus 6x, and then you have plus 13. So no variables of degrees are missing because it goes from 2, 1, and 0. Okay? So we write down our leading or we write down our coefficients. The understood coefficient for x squared is 1. It's an invisible 1. So you would have this 1, then you would have -6, and then you would have 13. So the first thing we do, we bring the 1 down. So 1. Then what do we do now? We multiply 1 times 3 minus 2i. That gives us 3 minus 2i. We add. -6 plus 3 is -3 minus 2i. So we get -3 minus 2i. Now we have to multiply -3 minus 2i times 3 minus 2i. So what you want to do here is use the FOIL method. So we'll do an aside. To figure out what that is. So 3 minus 2i, that quantity, times -3 minus 2i. So then you multiply 3 times -3 to get -9. 3 times -2i gives you -6i. -2i times -3 is +6i. And then -2i times -2i is a +4i squared. Notice that your middle terms cancel out, and you get -9 plus 4 times -1. Well, that's -9 minus 4, which is -13. So when you multiply -3 minus 2i times 3 minus 2i, that gives us a -13 here. We add 13. We add 13 minus 13, that gives us 0. This is our remainder. So then the question is 3 minus 2i a 0? Well, our remainder is 0, which means the answer to that question is yes. So this means our remainder is 0, which means 3 minus 2i is a 0, which means if you want to, so this is our answer, but because I'm also showing you how to use that to factor, that means P of x equals x minus the quantity 3 minus 2i is a factor. But because you know this is a complex number, whenever you have a complex number is a 0, you also know its complex conjugate is a 0. That we learned whenever we talked about complex numbers. So that means the extra information is that you have this times x minus the quantity 3 plus 2i. That's the complex conjugate. Okay? All right. So that's how you completely factor this in C, this polynomial in C. So our last example is D, part D. We have P of x is equal to x to the 5th plus 32, and C is equal to -2. Notice that there is no degree 4 term, no degree 3 term, no degree 2 term for x, and no degree 1 term. So all of those coefficients should be 0. And if you can identify that immediately, fine. If you need to write the following, do so. That means P of x is equal to x to the 5th plus 0 x to the 4th plus 0 x cubed plus 0 x squared plus 0 x plus 32. We're questioning if -2 is a 0, so in other words, is x plus 2 a factor? So you do your synthetic division. We write our coefficients down. Remember, this is an understood 1 here. So we have 1, 0, 0, 0, 0, and 32. So again, that came from choosing our coefficients. Remember, that's technically a 1 here. Then you also have 0, 0, 0, 0, and then 32. Then you synthetically divide. You bring down your 1. Multiply 1 times -2. You get -2. Add, you get -2. -2 times -2 is 4. Then you add 0 plus 4 to get 4. 4 times -2 is -8. -8 plus 0 is -8. -8 times -2 is 16. 16 plus 0 is 16. 16 times -2 is -32. 32 plus minus 32 is 0. 0 is our what? It's our remainder. Okay, which means -2 is a 0. Or in other words, x minus -2, which equals x plus 2, is a factor, which means p of x is going to equal the quantity x plus 2. Now remember, these coefficients here are the coefficients of the polynomial that's 1 degree lower than 5. 1 degree lower than 5 is x to the 4th. So these coefficients here are the coefficients of a degree 4 polynomial. So in other words, you would have that quantity, x plus 2, times 1x to the 4th minus 2x to the 3rd plus 4x squared minus 8x plus 16. And that's it. That is synthetic division. That's the division algorithm and the remainder theorem. Have a good day.